Hey everyone, this is Dr. Walker. In this video, we're going to go over a couple of examples dealing with unit vectors and vector addition. In this first example, we want to find the magnitude of the unit vector given the position vector r. We already know the answer to this question because we know that the magnitude of a vector, which we can write as the magnitude of r or just r, we know that that's equal to 1. We learned this in the previous video. But this is an exercise to work with unit vectors. So let's say we're trying to find the unit vector before we can find its magnitude. Then the definition, the unit vector is the vector divided by its magnitude. So we can write down the vector r, 3i hat plus 3j hat, and divide by the magnitude. To find the magnitude of a vector, we just use the Pythagorean theorem. So the square root of 3 squared plus 3 squared. If we had a k hat component, then we would just add it under the square root as well. So what we get here is 3i hat plus 3j hat divided by 4.24. And now what we want to do is, let's say that we're trying to find the magnitude of this vector. Then we have to use the Pythagorean theorem. So the x component is 3 over 4.24. We square the x component. Then the y component is 3 over 4.24. And we square that. And you can go ahead and put all of this in your calculator and you will get 1 as expected. So this was an exercise of finding the unit vector given the position vector and then finding its magnitude. Let's do one more example, finding the sum of two vectors. In this case, these two vectors have just an x and a y component. And we learned in the previous video that to add vectors, we just have to add the components separately. So the resultant vector is going to be adding, we can call this ax and bx. We add both of those together. 2 plus 2 in the I hat direction. And then we add the ay and the by for the j direction. So 2 minus 4, the j hat. So when we simplify this, we get 4 I hat minus 2 j hat. So we have added these vectors. We can leave our answer like this if the problem allows us to. And just to go on the side, I like to visualize things, so let's just take a quick look at this. Let's say we have 2 and 4 and 2, negative 4. Vector A was going this way, and then vector B had a component of 2 and then negative 4, so vector B went this way. So these are the two vectors that we added. I'm putting them tip to tail. So we know that the resultant vector is from where we started to where we ended. This is the resultant vector. And we can see that the resultant vector has 4 in the I hat direction, the x direction, and then negative 2 in the j direction. So it's just nice to visualize things sometimes. If we wanted to specify the magnitude of the vector, then we could use the Pythagorean theorem. And we square the rx and the ry. So we'll just write 4 squared plus the negative 2 squared. And that gives us square root of 20, which is 4.5. And then if we wanted to find the direction, it's going to be the inverse tan of ry, which is negative 2 over 4, And I like to just put the positive numbers in my calculator, make sure I'm in degree mode, and that's going to give me about, let's see, about 27 degrees. But that's not the final answer. It is this angle right here. So we could specify below the x-axis. Or if we want to specify the angle counterclockwise relative to the positive x-axis, then what we can do is we can say, well, this is the angle that we're going to use to specify this vector, which is going to be, let's call it phi. So phi is going to be 360 minus 27, and that's going to be 333 degrees. So there we have it. We have added vectors. We have used unit vectors to help us, and this will be useful once we start working with electric force and electric field vectors.